Let's see what happens when we apply our rules for drawing Lewis structures to HCN. If you haven't already watched the Lewis structure video, you may want to do that before you watch this video. Okay, so let's just follow our rules. First of all, let's count the number of valence electrons. So we know that hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5, and so we should have a total of 10 valence electrons. Since carbon makes 4 bonds, nitrogen makes 3 bonds, and hydrogen makes 1 bond, carbon makes the most bonds, so we're going to put it in the middle. The next thing we do is connect each of the other atoms to the central atom with single bonds. Next, we place the extra electrons in pairs to complete the valence shell of all the electrons, all the atoms. So we need 10 valence electrons total, and so far we have 2, 4. So that means we need 6 extra valence electrons, and we're going to start with the outside atoms. I can't put anything on hydrogen because it already has 2 electrons, which fills its valence shell. So I'm going to put the extra electrons on the nitrogen. So I have 2, 2, 4, 6, 8, 10. So I have a total of 10 electrons now around my Lewis structure. But I have violated a rule, and that is that I need to complete the valence shell of all atoms. So we need to figure out how to give carbon 8 electrons. Nitrogen has 2, 4, 6, 8, but carbon only has 4, 2, 4. So somehow we have to figure out a way, without putting any more electrons in, because we have our 10 electrons in there, to give carbon 4 more electrons, right? So this is where we have to add a rule to our 4 rules. So we'll need another rule. So our last rule reads that if the central atom does not have a completed valence shell, which is the case here, we have to move electrons from the outer atoms to make double or triple bonds. So in other words, I can take these 2 electrons and share them between the nitrogen and the carbon, and these 2 electrons and share them. That gives carbon 4 extra electrons and doesn't take any away from the nitrogen. So if I redraw that, I'm going to end up with a representation that looks like HC. Now I have 3 bonds between the nitrogen and the carbon, and I have only 2 lone electrons, or 1 lone pair on the nitrogen, because I've used 2 lone pairs to make an extra 2 bonds so that carbon will have 8 electrons around it. So now if we check, we have 2, 4, 6, 8, 10 valence electrons. That's how many we need. Hydrogen has 2 electrons. That fills its valence shell. Carbon has 2, 4, 6, 8. 8 fills carbon's valence shell because it's in row 2. And 2, 4, 6, 8 electrons around the nitrogen. So the nitrogen has a full valence shell. And so this structure is a good Lewis structure for HCN.